Welcome back to 3 Inquisitive Kids. In this video, we will be learning about exponents of rational numbers. Again, our course outline for this unit includes rational numbers, the number line, and the absolute value. And we learned about adding, subtracting, multiplication, and division of rational numbers. So now, what are exponents of rational numbers? Our learning goals for today is to understand and master the concepts and meanings of powers, bases, and exponents of rational numbers, and be able to use exponents in problems. Introduction. The picture below is a poster posted in front of an elementary school in Japan. Do you understand its meaning? It seems like if you get a bit better at something every single day, you can see it's 1.01. And you keep multiplying that to what you already have after 1 year, which is 365 days, you will be left with 37.8 times than what you had before. So that's about 40 times. And if you get just 0.01 worse a little every day, so you're going to multiply 0.99 to your number every single day, after 365 days, which is 1 year, you will be left with 0.03. It's basically nothing. So this tells you that if you improve just 0.01 every single day after 1 year, you will have 40 times than what you had before. Handmade ramen noodles is a traditional noodle dish that originated in China. When making, the ramen master needs a ball of mixed noodles, so it just needs a ball of dough into a long strip and then stretches the two ends. Then he folds the strip in half, stretches it, and then folds it over in half again. After repeating this, it will become a lot of thin noodles. If you repeat this process 10 times, can you figure out how many noodles there will be? Before kneading, we have one long strip of dough. After kneading once is when you stretch it out and fold it in half. You have 2 noodles. After kneading twice, you stretch it out and then fold it in half and pull again. There's 2 times 2 strands of noodles, which is 1, 2, 3, 4 strands. And after kneading thrice, it's 2 times 2 times 2, which is 8. So you can see we're multiplying 2 to the previous number every time we knead. How many noodles are formed after kneading 10 times? Express it in mathematical terms. After 10 times, it would be 10 2's being multiplied together. How many noodles are formed after kneading 100 times? Use a formula to express it in mathematical terms. How many 2's are multiplied? Well, it would be 2 times 2 times 2, 100 times. But there's 100 2's in this product. Is there a simpler way to express such a long formula? Well, in math, we would just write it like this. 2, it's a number that's being multiplied, and 100 on the top right corner. So that's how many times it's being multiplied. When an n number of a's are multiplied, it is written as a to the nth power. That's how you would read this. And you pronounce it as a to the nth power. Here you can see we have a bunch of a's being multiplied together, and there is an n number of a's being multiplied. So we write it as a with a small n to the top right corner. The exponent in this case is n, is how many times the base is being multiplied. And the base is what number is being multiplied over and over again. This entire thing is called a power. You can see that exponents are just essentially repeated multiplication, just like how multiplication is repeated addition. If you have any number to the second power, you would call it a square, and if you have any number to the third power, it would be called a cube. So if we had a to the third power, we would call it a cubed. And if we had a to the second power, we would call it a squared. The base number of -5 squared is -5, and the exponent is 2. -5 squared means 2 -5's are being multiplied together, and we read it as -5 to the power of 2, also read as -5 squared. Reminder, when the base of the power is a fraction or a negative number, the base should be bracketed or be written in parentheses. In 1/2 to the 6th power, 1/2 is the base number. 6 is the exponent, and it is read as 1/2 to the power of 6. Example 1. Calculate. For the first expression, we simplify it down into -64. The second expression is +16, and the third expression is 3 2/3 being multiplied together. which is negative 8 over 27. Did you find any patterns for calculating negative numbers with exponents? Here you can see that all the bases are negative. You can see that when we had an odd exponent, the product was negative. If we had an even exponent, the product was positive. Conclusion. The odd power of a negative number is negative, and the even power of a negative number is positive. Any positive power of 0 is 0. Can you quickly determine whether the following powers will be positive or negative? The first one we have is 16 to the power of 5. The base is already positive, so no matter what, the power will be positive. It's the same thing for 25 to the 4th power. It will also be positive. Negative 7 to the 9th power is going to be negative because the base is negative and the exponent is an odd number. The 4th expression will be positive because even though the base is negative, the exponent is an even number. And the 5th expression will be negative 1 because its base is negative and its exponent is an odd number. And the last expression in the top row is going to be positive because the exponent is even. And it's the same thing for decimals. This is going to be positive. Negative 1/8 squared will be positive. 0 squared will just be 0. And a squared would be positive. We know that a is greater than 0. And even if a is less than 0, a squared will still be positive because the exponent is even. Now I want you to use mental math. Our answers is 1, 1, positive 1, positive 1, negative 1, and negative 1. Any power of 1 is 1, and the odd power of negative 1 is negative 1, and the even power of negative 1 is 1. When the base number is a negative number or a fraction, the base number must be bracketed, for this is also the way to identify the base. You'll see why in just a second. Here we have 10 squared, 10 to the 3rd power, 10 to the 4th power, 10 to the 5th power. 10 squared is 100, 10 cubed is 1,000. 10 to the 4th power is 10,000, and 10 to the 5th power is 100,000. Negative 10 squared is 100, negative 10 cubed is negative 1,000, negative 10 to the 4th power is 10,000, and negative 10 to the 5th power is negative 100,000. What patterns did you notice from the results above? When you have 10 as a base, the number of zeros is equal to the exponent. When we had 10 squared, the exponent is 2, and our answer 100 also has 2 zeros in it. And any power of a positive number is a positive. Even powers of negative bases are positive, and odd powers are negative. Now, what's the difference between negative 3 squared and negative 3 squared? Are the results the same? Well, when we write these two expressions, this first expression has parentheses, and the second expression does not have parentheses. And when we pronounce or read this expression out loud, it would be negative 3 squared. And we read the second expression as the additive inverse of 3 squared. The meaning of the first expression is 2 negative 3's being multiplied, which is negative 3 times negative 3. The meaning of the second expression is the additive inverse of the product of 2 3's, which is a negative 1 times the product of 3 times 3. So the result of the first expression would be 9, and the result of the second expression would be negative 9. According to the order of operations, we first do the exponents. So here we don't have any parentheses. It's 3 squared, which is 9. And then we multiply this negative 1 to it, which gives us negative 9. So now you know that if the base number is a negative or a fraction, the parentheses must be added. And if you're wondering why do we have to add it if it's a fraction, it's because if you don't add it, they might think that the exponent is only part of the numerator. Here's some practice. Calculate these two expressions. 1.5 times 1.5, we already know that the product will be positive, and we get 2.25. And the solution for the second problem is 25 over 9. You first convert this into an improper fraction. Divide a square piece of paper with a side length of 1 into 6 parts as shown in the figure. The area of triangle number 1 would be 1/2. You can see it's 1/2 of the entire square, which has an area of 1. The area of triangle 2 would be 1/4. The area of triangle 3 would be 1/2 of what's remaining. So it would be 1/8. The area of triangle 4 would be 1/2 to the 4th power. The area of 5 would be 1/2 to the 5th power, and the area of number 6 would be 1/2 to the 5th power as well. Complete the following and fill in the blanks. Here we have a sequence: 8, 16, 32, and 64, and so on. The nth number will be expressed as blank. So how would you write this in mathematical terms, in the terms of n? You can see that the first number is 8. So that's 2 to the 3rd power. The second number is 2 to the 4th power. The third number is 2 to the 5th power, and the fourth number is 2 to the 6th power. And this is the first term, the second term, the third term, and the fourth term. So the nth number, it would be expressed as 2 to the n plus 2 power. Sequence number 2, we have -4, 8, -16, 32, -64, and so on. So what would the nth number be? I want you to pause the video and do some thorough thinking by yourself first. Well, the nth number will be -1 to the nth power times 2 to the n plus 1 power. This is getting more complicated, so it might require some thinking. So let's see if this makes sense. If we were talking about the third term, which is -16 here, n will become 3. You can see that -1 to the 3rd power is -1 times 2 to the n plus 1 power. 3 plus 1 equals 4, so 2 to the 4th power equals 16. That gives us -16. So you can see that we just confirmed this expression. Our third sequence is 1, -4, 9, -16, and 25, and so on. Let's see if we can find a pattern here. Here we have 1 squared, which equals 1. The absolute value of -4 is 2 squared. The absolute value of 9 is 3 squared. The absolute value of 16 is 4 squared. And the absolute value of 25 is 5 squared. Something time, right now we're just only caring about the absolute values here. Something times n to the 2nd power, but that's the absolute value. Now what do we do with these numbers that have negative signs in front of it? Well, it would be -1 to the n plus 1 or -1 power. So our answer would be these two expressions. Both of them are correct.